Assalamualaikum warahmatullahi wabarakatuh and good day everyone. In today's video we are going to talk about the inverse of a matrix. Some matrices can be reversed or can be inversed and some can't. The key is to find out which matrices can be undone and how to calculate the matrix that performs that reversal. So, what is the key to determine whether a matrix can be reversed or can be inversed or not? So the key is actually lies in the determinant. Remember, in our previous video, we talked about determinant, where the calculation of determinant will give you one value. For example, let's take A determinant, which this is the symbol, and it will be, when you do the determinant, you will get a value, any value. So if the determinant is equal to 0, meaning that that matrix cannot be inverted. But if the calculation of the determinant give you a value that is not equal to 0, it is an indicator that that matrix is invertible. That matrix can be reversed. That matrix can be undone. So formally, we say a square matrix of A is invertible if there exists another matrix, let's call it B, that when multiplied give an identity matrix like this one. And later, matrix B here will be denoted as A inverse. And remember, for the case of reversing a matrix like this, actually it is a unique case. For this case, only one matrix that can undo A, which is B and B alone. Now let us start small. Let's discuss theorem 2.1. If A is in the form of this matrix A, B, C, D, 2 by 2 square matrix, then A is invertible if AD minus BC not equal to 0. Alright, please remember that AD minus BC is actually a formula for determinant. Right, determinant. So when AD minus BC not equal to 0, as we have discussed before, it indicates it is invertible. So when it is invertible, we can use this formula to find the inverse of A. So 1 over the determinant of A, AD minus BC, times with a metric, right, a special metric, which is just by swapping A and D and then changing the signal of the sign of B and C, and then multiply everything by 1 over the determinant. So this calculation will give us the determinant of the inverse of A. So let's look at this example. Right, find the inverse of 3, 4, 5, 6, first we check its determinant. So 3 times 6 minus with 4 times 5 give us -2, which is not equal to 0. So it is a signal that A is invertible. So we can proceed with the calculation of the inverse for A. So just input everything. Okay, this is 1 over the determinant, and then swapping A and B, right? So it becomes 6, 3, and changing the sign of 4 and 5, so -4, -5. Just multiply everything. So this is the inverse of this. Later on you will see that when you multiply this with this, you should get an identity matrix. Next, let's look at the inverse of 3 times 3 matrix and higher order square matrix. Right? For bigger matrices, we use a formula that include adjoint in it. So basically you already learned the idea of how to find adjoint, which is by transposing the cofactor of the matrix and then multiply it with 1 over determinant. Let's look at example. So of course, just like we did before, right? Before we conduct any matrix, we'll need to check on whether it is invertible or not, and how to check it through determinant. So how to do determinant for 3 by 3 like this, right? One way is by using cofactor expansion, which is by choosing either one of the column or rows. So for this case, they are actually choosing the first column to conduct cofactor expansion. So later on you can try to calculate, and just by looking at the answer scheme, you will see that the calculation end up with getting 14, which is not equal to 0. So we know that this matrix is actually invertible. So next, now that we know that it is invertible, the next thing is to find the adjoint. So how to find the adjoint? Again, first we need to calculate for the cofactor, for the minor and cofactor for each element, right? So let us just do one of it, just to refresh on how to calculate the minor and cofactor. Let's look at C11, right? So C11 equal to -1 to the power of 1 plus 1, right? I times j times with the minor. So what is the minor for C11 at this point? So C11, so just exclude the 1, 1. So focusing on this, so it's actually this times this minus with this. So -1 times -2 minus 1 times 4. So what is actually giving us? -1 to the power of 2 is 1 times with -2, 1 times 2, -2 minus with 4. So this gives us negative 2. So this is how you get negative 2 here. Alright, so the same kind of operation goes for other cofactor in this element. So for C12 you will do negative 1 to the power of 1 plus 2 and then times with a minor that exclude this line. So 1 times negative 2 minus 1 times 1. So you can have a look at the previous video that talking about cofactor and minor. So by doing that you will get all of these cofactors. So rewrite the cofactors in this cofactor matrix, right? And then from this we transpose it, right? So transpose it. What is transposition? Which is changing row and column. So negative 2, 3, 5 will be of this row will become negative 2, 3, 5 in this column. Everything is actually changed. So this second row become this second column, and so on. So and this is actually the adjoint. So now that we have this adjoint, we can proceed by dividing and multiplying 1 over its determinant to the adjoint, which later on just simply like a scalar multiplication. So 1 over 14 times negative 2, 1 over 14 times 14, 1 over 14 times 4, so on and so forth. This will give you this new matrix, which is the A inverse of the original matrix above, which is this one. That is how you find matrix using adjoint. Right? Thank you.